Hello friends, so today we're going to discuss another problem from the latest binary search problem series I'm working on. This is another medium problem, and this is also a problem similar to the medium problem I have already uploaded. So you can also check that out. And this series will consist of around 5 medium problems and also 7 hard problems. So stay tuned in this video series. So this is a problem named Koko eating bananas, in which Koko loves eating bananas and there are n piles of banana. The ith pile has piles of I banana. So you can assume that there is some different piles and every pile has some different amount of bananas in it. I'm just drawing out some random piles. Okay, so let's assume that this has, let's assume 5 piles, this is 7, okay, this is also 4, this is 2. Now Koko can decide her banana per hour speed equal of k. What does this mean? Like Koko can eat at a speed of k bananas per hour. Like which Koko can decide. Each hour she'll choose some pile of bananas and eat k bananas from that pile. So let's assume that for this the k is equal to, let's assume, equal to 3. So like first maybe Koko can choose this pile, eat 3 bananas from here, and now 2 bananas are left. So what you can see here is she eat all the bananas. So if the pile has less than k bananas, she eat all of them instead and won't eat any more bananas during this hour. What does this mean? It means that it will not happen that if her capacity of Koko is equal to 3 and in the first hour she will eat 3 bananas and now it, like this pile has only 2 bananas, so she will eat 2 bananas here and 1 banana here. No, she will only eat or complete the one pile irrespective of how many time or how many hours it will take, and then only she will go to the next pile. So how many time it will take to like finish off this pile equal to 2 hours. So first this and this. So this is again 6. So it has 7. So 3, 3 and 1. So it will take 3 hours. So it will take 2 hours and it will take 1 hour. So I hope you get the point how like Koko is eating the banana piles. So now Koko likes to eat slowly but still want to finish eating all the bananas before the guard come. So return the minimum integer k, which is the speed. You want the speed at which Koko should eat the bananas such that she can eat all the bananas within h hour. So she wants to eat all the bananas within h hour. So this is also the constraint. You have to tell k. So as you can assume, this is also monotonic function. How? You can tell that if my speed is equal to k, let's assume that these are the integers which is given to you. If my speed is, let's assume, 100, maybe let's assume, then also, and my r is, let's assume, what is the total of this? This is 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. So this is 8 hours. So let's assume if my speed is 8, like the time given to me is 8 hours, then 3 is the valid answer. Like 3 is the possible answer, because I can, if my speed is equal to 3 bananas per hour, then I can complete all the piles within 8 hours. But let's assume that my speed is equal to 100 bananas per hour. Then I will complete this pile in 1 hour, I will complete this pile in 1 hour, this pile in 1 hour, this pile in 1 hour, and I will complete all the piles in 4 hours total, which is less than 8. So this is also valid because I want the condition that I should complete eating all the banana piles is less than or equal to this h given. So this is also valid, this is also valid. But if my speed is 1, then I will complete this pile in 5 hours, this pile in 7 hours, this in 4, this in 2. So which is less than 8, or like, sorry, greater than 8. So this is not valid. So as you can see, there is some point, some minimum speed after which if you increase the eating speed, then you will always, like, you can complete eating all the bananas in the given hour, else before that you cannot. So this is like a monotonic function. So you will do the same thing. So you will take 2 pointers, one left and right. You have to always have to define what is my time limit, or like what is my range. So range of this will be my number of piles which is given to you. A number of piles is the number of, like, n, the number of piles given to me. That's the range, because that's the range I have to iterate. I have to complete all the piles. Or okay, no, sorry. My actually speed is for the range k. I have to eat for the k bananas per hour. Sorry. So if I want to eat k bananas per hour, okay, and see if there is some pile, like there is some pile, let's assume that what is the maximum value of pile? Maximum value of pile is 10 to the power 9. So it can also happen that one pile is 10 to the power 9 So for eating that pile, maybe like in, I have to eat that pile. So if I have to eat that pile, my maximum time can be 10 to the 9. Okay, so or actually the guard will take 10 to the 9 hour. So what will I think here is that my left pointer is equal to 1 and my right is 10 to the 9. I have added 1 as a buffer value, and I'll do the same thing because it's a monitoring function. I've already like made 2-3 videos. You can understand by this point very easily how I'm writing this while loop. While is less than equal to r, mid is the mid value. I'm just making this OK function, which is telling out whether for this particular mid value, which is actually telling us what is my speed. Mid is actually equal to k. What is my eating speed? For this eating speed, whether this OK function is returning out true, then if it is returning out true, then this is a possible candidate. Then my r is equal to mid, else my r equal to mid plus 1, and returning out L. So how this function is working, I will take the input of mid, piles and h, move from over all the piles from left to right, finding out. So let's assume that I have a eating speed of 3. Now how much time will it take to eat up this pile of size 5? It's actually the seal of 5 divided by 3. So that's what I'm finding out, the seal of 5 divided by 3. This is actually finding out the seal. If finding out the seal, I am actually always like for every time period I'm calculating the total time. So total will show the total time taking to exhaust all the banana piles. So total plus equal to x. X is the time to exhaust one pile. So I'm iterating over all the piles, and then after that in the end I have to return out that whether, or check that whether the total time is less than or equal to h. Then only I can exhaust all the bananas. Like for the given condition, I can exhaust all the bananas in total time. So if total is less than equal to h, then my answer is okay, I'm fine. This possible scenario of mid is fine. Else if this is not fine, I'm taking a lot of time to like exhaust all the bananas, then this will return out false, and then I will make my mid or like my left pointer equal to mid plus 1. If this is a valid configuration, then my right is mid, and in the end return out L, which is actually storing the possible answer. I hope you get the gist of how I'm solving binary search problems. I've already uploaded, like this is the 5th problem, and I will upload more problems. So but till now, if you have followed through the series, you will get or understand how binary search is working and how the problems are solving. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you next one. Keep coding. Bye.